Section 4.3, midpoint. The objective for this lesson is that you should be able to find the length of a segment using midpoint. All right, we're going to skip the construction here and go right to the vocabulary, the definition of a midpoint. So a midpoint is a point on a segment that divides the segment into two congruent segments. Let's go ahead and answer the questions here for example number 1. So using the location of these points in a number line, true or false, segment AB is congruent to segment BC. All right, because the distance between A and B are 3 units, and the distance between B and C are also 3 units. That means that these two segments are congruent. Part B, true or false, BC, segment BC is congruent to segment DE. All right, that statement is false. BC has a length of 3 units. DE has a length of only 2. Part C says name the midpoint of AC. Okay, because AB and BC are congruent, we know that if we look at the entire bigger segment of AC, that there is a midpoint, and that midpoint is located at point B. Part D is asking you, where would you plot the midpoint of segment AD? Yep, we would plot it right at -4. Because from A to D is 8 units long, so the midpoint is supposed to cut that into 2 congruent segments, so that would need to be right here at -4. That's the location of the midpoint. All right, example 2 says, given that M is the midpoint of segment AB, find the measures of, so there's a couple typos here. It says find the measure of AM and MB. Okay, because we know that M is the midpoint, and we know that these two segments on either side of the midpoint are exactly the same length. And because A to B is 26, M is the midpoint, that means each of those segments must measure 13 units. Number 3, P is the midpoint of RS. Find the length of RS. Again, because P is the midpoint, then we know that these two segments on either side of the midpoint are the same length. So if R to P is 7, that means P to S is 7. So that means the whole entire length of RS is 14. All right, let me give you some time here to work on example number 4. We are finding the value of X and the length of AC, BC, and AB. All right, since we know that C is the midpoint of segment AB, that means that segment AC is congruent to segment CB. So that leads to us saying that the length of AC is equal to the length of CB. So therefore, we can set those two expressions for equal to each other. 2x plus 1 is equal to 3x minus 4. Solving for x, we get x is equal to 5. All right, so again, here off to the side, showing you all the work, which you need to make sure you're doing on quizzes and tests. Trying to find the length of AC. We're plugging 5 in for x into that expression for AC. We get AC is equal to 11. Find the length of CB. Again, plugging that value of 5 in for x in the expression for CB. I got CB is equal to 11. Finding the length of AB, knowing again that AB is AC plus CB together. AB is equal to 22. Again, modeling all the work that you need to show me for problems like this on quizzes and tests. Make sure you get this down. Okay, so I'm now moving on to the definition of a segment bisector. All right, a segment bisector is a segment that passes through the midpoint of another segment. So for example 5, you're given that DE, segment DE bisects segment AB. So by definition, segment DE passes through the midpoint of segment AB. So therefore, point C is the midpoint. And because C is the midpoint, then we know how to solve for x. So now see here off to the right, I kind of written a series of statements that logically follow each other. Starting with statement number 1, right, we're given that segment DE bisects segment AB. So because of that, we can now make the statement that C is the midpoint of AB. And by definition of segment bisector, right, C has to be a midpoint of AB. And because we have a midpoint, that means segment AC is congruent to segment CB. And because those two segments are congruent, we know that their measures are equal. So AC is equal to CB. And with that statement, we are able to set those two expressions equal to each other. 8x minus 3 is equal to 6x plus 11. All right, again, here's an example of what I'm expecting from you for quizzes and tests. When I ask for a series of logic statements, this is what I'm looking for. All right, so we're going to finish off here with examples 6, 7, and 8. So we're going to be given some information, and we want to be able to state what we can conclude based on that given information and state a reason for our conclusion. So number 6 says D is the midpoint of segment FE. So what can we conclude? Well, we can conclude that segment FD is congruent to segment DE. What would be the reason? Well, if there is a midpoint, then we know there has to be two congruent segments. Example 7, we are given that segment OK is congruent to segment KP. Based on the diagram, what can we conclude? So based on the diagram, we can conclude that line JM bisects segment OP. And what's the reason? Well, if a line passes through the midpoint, and we know that K is a midpoint because we have OK and KP as being two congruent segments. So if a line passes through the midpoint, then it bisects. Finally, example 8. Segment XY bisects AC at B. What can we conclude? All right, so we need to be careful with a problem like this one. Right? The only conclusion that we can make is AB, segment AB is congruent to segment BC. And given that XY bisects AC at point B, we know for a fact that AB is congruent to BC. The most common mistake that students make here is they're going to say that XB is congruent to BY. Right? Again, we don't know that to be true. Okay? It doesn't say that AC bisects XY at B. Right? It only says that XY bisects AC at B. So again, this is a statement that we do not know is necessarily true. Okay, so the reason why AB is congruent to BC, if a segment bisects another segment, then the result is two congruent segments. All right, let's go ahead and move on to the 4-3 homework.